Here we can see that this is most of the work is in modifying the cost functions, creating new classes of cost functions, and the first thing we had to do was to derive a derivative for the cross entropy function. And then the log likelihood function, which takes the result from softmax and returns the negative log of the one with the highest probability, and that's the cost. And here we have all the different activation functions. An extra definition for undo was added for when we want to undo the activation for the last layer to reapply it for a different activation function when a different one was specified in set parameter. So we added undos for each of them except for softmax, which can only be applied for the output layer anyway. For ReLU, we use a leaky version because when it returns 0, the output was NaN, so instead we give it a very small negative value, and that fixed the problem. Here we have L2 and L1 regularizations, where epsilon and a clipping function was introduced for, again, a NaN output for when it's too small. For the dropout, we define a new function where we take the percent and then we made a mask based on how big the biases and weights are in the hidden layers. For the mask for the hidden weights, we use the repeat function to duplicate values in the mask for the biases. So if there were a 0 in the bias mask, the 0 will be repeated for the mask for the weights. So the weights is 0 when bias is 0, thus canceling out the node. To implement dropout, we go to stochastic gradient descent and we call the dropout function once within the loop for when if a dropout percent is greater than 0, and updated the default weights again at the end of mini batch update, so the program should remember the nodes that were dropped and only use the drop nodes during one update. So here we see that everything runs correctly. This one is for when a dropout is 0.1. The cost is decreasing consistently and kind of moves around a little. And then here we have Iris 423. Here we see it works for both datasets. Here we can see this one uses tan for the output layers. And the cost drops consistently as desired, even though the number is a little different from what was given.